My name is Darren Arney, and thank you for attending my SLAS 2021 lightning talk entitled Restarting the Laboratory Automation Lifecycle. Now in this talk we'll discuss a few examples of the specific challenges and solutions relative to reintegrating legacy workhorse automation systems that can provide the benefit of a familiar user interface for researchers, reduce costs and downtime relative to designing, installing, and validating entirely new automation systems, and the benefit of the collaborative process that comes from working start to finish with myself and the many other members of the Biosero team. So the first thing I think we need to look at is the past, which is your current experience or previous experience with a system that has now found itself at a crossroads. The biggest crossroads we usually find with these systems is the move from from Windows 7 to Windows 10. Now, since Windows 7 isn't supported by Microsoft for security updates anymore, if you have any automation systems that are running on that, it's unlikely that your IT will allow you to connect to your organization's network anymore. And this is obviously very important for connecting to databases, LIMS, all kinds of things. So the way we get around that in GBG is by any individual instruments that need to be connected to Windows 7 can still run off of that system. We'll just isolate that from our GBG computer by using the GBG remote client to run a smaller, more light version of GBG on the Windows 7 machine, so it's still connected to GBG, but is isolated from the network, which is, pursuant to most IT guidelines currently. Also, the other thing most common with legacy automation systems is that when you bought this thing, probably 5 or 10 years ago, you probably bought it to do one thing. And if you were still using it 10 years later, it's probably been doing that thing pretty well. But we wouldn't be in science if we didn't constantly question processes and how we run things and try to always find a way to make something better. So usually, you probably had a list that's gotten either short or pretty long over that amount of time of little quality of life improvements you'd like to make your automation and your fellow lab technicians' automation experience a lot better. So we tend to sort of roll all of these things together along with any other legacy process concerns you might have, such as like plate batch sizing, running concurrent experiments, being able to just replicate the thing that you were doing before but on a new system. So the way we do that is by using Green Button Go as a replacement automation scheduling software. Now I'm sure you've heard, if you've heard any of our other talks, the Green Button Go is an instrument-agnostic automation scheduling software, meaning that you can bring any instrument from any vendor over to us and we'll be able to reintegrate it using GBG. Now, the way we simplify that generally is by starting a collaborative process by you calling a sales account manager or emailing or anything else. They'll connect you with myself or another member of the applications team, and we'll go from a very high level down to a very granular level by the time we're done, each step in your process, how we would be able to meet those needs of your existing process with Green Button Go as it sits, and then also consulting you on any sort of improvements you want to make. So whether or not you want to add another stacker or another sealer or another plate washer, or whether or not you just want to have it send you a text message every time that a run's done. All of those things we want to make sure we collect as part of the package that we're going to be delivering to you eventually. And I think probably the best way to highlight some of those examples of different improvements we can make and different challenges that we've overcome is by showing a couple of different examples. Now, the first one that I'll show here is a cell line development work cell that was running on a different automation scheduling software that we reintegrated a little over 2 years ago. Now, this system had a couple different challenges that we ran into. Mainly, first, that there was a fixed batch size for a number of plates for imaging runs that were going to take place on the plate imager here. Now, that meant if you wanted to image 3 plates and the batch size was fixed at 10 plates, you had to waste all this time running your initial 3 plates, then imaging 7 blank plates, and wasting all that space on your hard drive, all the time in the lab, and just making sure everything else was up and running. So that was the first thing we fixed. The next thing was OneStop user interface for the run startup, and I have that set up as the next slide in this presentation, but it allows us to collect all of the parameters that go into all the steps for this 2-week process into one screen that the user can touch once and then come back 2 weeks later when they get an email saying that their plates are finished, they've been picked into destinations, and the run is now complete. So you may have heard me just say that this was a 2-week process. Now previously, this system was only able to run one experiment at a time. So that meant if in those 2 weeks another user wanted to bring another another experiment and put it on this work cell, they either had to wait or had to dangerously kind of juggle around when the system expected to be doing something next so that it could still produce what it needed to, but get out of the way of the run that was already scheduled. This is something we eliminated with GBG by adding in a group ID string to tie all the plates together, and also by adding a dynamic storage allocation and population script to make sure that the space available in these incubators was used in the most efficient way possible. So it was only assigning and then deleting plates out of storage as they were added to or removed from the system, and not setting it at a fixed set of plates in a fixed location in either of these incubators. Now, when this system was first reintegrated, we had a bioelectric liquid handler, a laconic incubator, and a clone select from molecular devices plate imager. When we initially reintegrated, we added one more additional laconic, as you can see in our design here. And then about a year later, after we finished the reintegration process on this system, the customer decided that they wanted to upgrade the imager they were using. So we replaced the clone select imager, which was sitting over here, with a Selenium cellmetric imager, which they are currently using on the system. Now, this is just a good way of showing how the hardware has sort of picked up in speed from the time where this work cell was initially deployed, but the fundamental assay they were trying to run hasn't really changed. Now, Green Button Go enables them to do that science with the upgraded hardware and kind of come up to speed with the rest of the other labs that are doing this type of work, just by replacing one piece and then not having to reconfigure or reintegrate their entire process as part of changing out their imager, basically. So over here, real quickly, I'll go through the OneStop user input screen they have here. I always like to highlight how they have a snapshot of all the runs going on concurrently in the system. There's also a place here to schedule all of your run days, a way to edit this group ID string I was talking about that would tie all of your other experiments together, and the other assorted general run parameters that you might need for these types of sort of cell line development assays. So these next two examples are pretty related. The first one is actually the downstream assay of the second one here I'll show you, but generally what we need to know for both of these work cells is that they were doing everything they needed to do already. The main issue again was that the computers that they were running on was running on Windows 7, and the overarching scheduling software that this system used is no longer supported on Windows 10. So this gave us an opportunity to come back and replace all of, none of the actual hardware except for the robot arm, but replace the automation scheduling software with GBG. This allowed us to sort of simplify the data hooks of where everything was, because in the old automation scheduling software they were kind of tied in at every individual point where they might be needed, and it made for a very clunky user interface and experience when the system got along in its years and various patchy updates were made to the workflow. We also were able to simplify the instrument protocols, since now that they were locked down to only doing their liquid handling duties, they were much easier to read and modify as needed. And again, we were able to streamline the user input in just a one-stop location for the types of data they would need to put in to get a run off the ground. So, as I kind of wind down my time here, I'll show one last example, which is the step upstream of the last work cell I showed. This system does a number of different compound distribution operations, mainly plating racks of tubes into different pieces of labware, be them 96 or 384. All of that, again, was driven by a network-based database that this system needed to contact, and once Windows 7 was sunsetted, it couldn't contact that database anymore, so we went back and reintegrated this whole process with GBG again. The main thing worth noting about this system is that it's fully autonomous, runs 24/7, there is no user input. It just silently takes requests from an internal portal developed by that customer's IT department to allow them to place orders for different compounds, and this system plates them out after a different process further upstream from itself. But we were able to uncouple this system from the wiring I/O module that was initially present as it was put together. So for both of these, we did have to do a fair bit of rewiring for everything, but at the end of the day, everything's still on GBG, everything's on Windows 10, everything's happy and running, currently, probably as we speak. And I think that's pretty much what I have for now. So I'll get ready to take questions here directly, and thanks for your time and listening to my talk. Thanks.